Today we will graph and solve systems of linear inequalities in two variables. So a system of a linear inequality is the same as systems of linear equations. It's a set of two or more linear inequalities containing two or more variables. The difference is there's going to be multiple solutions of linear inequalities. It's going to be all of the ordered pairs that satisfy all of the linear inequalities in the system. So we'll take a look at what that means. First, let's look at some ordered pairs and see if they're solutions of systems of inequalities here. So we have 0, 2, and we're wondering if that's a solution of y is greater than 2x and y is greater than or equal to x plus 1. So let's find out. Remember, this is my x value, my y value. So let's plug them into the equations here. Is 2 greater than 2 times 0? Yes, it is. 2 is greater than 0. Is 2 greater than x plus 1? 0 plus 1. Yes, 2 is greater than or equal to 1. So that checks out. What about this one? Is 1, negative 3 a solution of, and then we have y is less than x plus 5, and y is greater than or equal to 2x minus 2. Remember, this is my x, this is my y. Let's plug it in and find out. Is negative 3 less than 1 plus 5? Yes, negative 3 is less than 6. That checks out. Let's try this one. Is negative 3 greater than or equal to 2 times 1 minus 2? Is negative 3 greater than or equal to 0? No, it is not. So 1, negative 3 is not a solution of this set of linear inequalities. Okay, so here we have a system of linear inequalities. We have y is less than 2x plus 2, and x is greater than or equal to negative 1. So I'm going to graph these in different colors here. This is going to be my red line, and this is going to be my blue line. All right, so I'm going to graph this starting off, just like we would any other inequality. I'm going to start off with the 2 points and then determine if I need a dashed or a solid line and then figure out which direction to color it. So this is set up in y equals mx plus b form, or y is less than mx plus b. So I'm going to graph my y-intercept, which is 2, plot that, and then my slope is 2. So I go up 2 and over 1. Now we are going to need a dashed line because it is less than and not less than or equal to. So let's make this as straight as I can, which isn't looking too good. Something like that. And then we're looking at less than. So all of the y values that are less than this is what we want to include. All right. Now we need to look at x is greater than or equal to negative 1. Well, this is my x equals negative 1. And it's less than or equal to, so it's going to be a solid line. So I can actually just put this line right here. It's going to look something like this. And we're looking for all of our x values that are greater than or equal to. So it's going to include all of this. So my solution is actually going to be wherever these two lines and shaded areas interlap. So my solution is actually going to be this whole area here. That is my solution. It's where the two lines and shaded areas overlap. So everything here is my solution. So any point in here, any ordered pair in here would be a solution of this system of inequalities. Let's look at one more example here. So I have y is less than or equal to 1/2 x minus 3. That's going to be my blue line. And then y is greater than 1/2 x plus 2. That is going to be my red line. So let's start with my blue line here. -3 is my y-intercept. And my slope is 1/2. So I'm going to go up 1 over 2. And it's going to be a solid line because it's or equal to. And then I'm going to shade in all of the y values that fit the build there. Everything less than or equal to. All of these. Alright, now let's work with my red line. Y is greater than 1/2 x plus 2, so I go up 2. That's my y-intercept. And my slope is 1/2, so I go up 1 over 2. I'm going to do a dashed line this time. A dashed line. You'll notice that these lines are actually parallel, and I need all my y values greater than. These lines are parallel. They will never intersect because they have the same slope. And because of that, these shaded areas are never going to match up. So this is an example of a system of linear inequalities with no solution. There is no solution. They will not share any shaded areas. If you would like more practice, you can go to IXL underneath Algebra 2, sections F1 and F2.